problem is if you have a triangle, right? And you have a line somewhere here that's parallel to the base. And then you join these two up. The intersection, when extended to the top, bisects the bottom. Yeah? That's what we want to show. That's the question. So if you have this set up, show that the base gets bisected. So maybe you want to label it's like x and this y. This could be like little x and this could be little y. You know? So your experience would be with similar triangles, and a lot of them come from parallel lines, right? So I think that's might be a good starting point. So for example, if you just had the triangle with the parallel lines, right? And you didn't worry about the intersection thing. Could you see from that, you would get that x over x is the same as y over y. X over x equals y over y. I guess because, you know, like there's similar triangles everywhere here. So if you look at the left triangle, you know, it's similar because this angle is equal to this angle, this angle is equal to this angle. So the ratio of the base will be equal to the ratio of these to the long side. Okay? And same on this triangle. And then both of them are actually equal to the ratio of the middle, the common thing, right? To the long side. So they must be equal to each other. Does that make sense? They're both equal to the ratio of this to the whole long thing. So they must be equal to each other. Yeah? Okay. But now if you consider the thing with the other two lines, right? Can you see that this triangle here, yeah, is similar to this triangle here? Because you have, like, these angles are equal because they're alternate angles, right?
Yeah.
And same with this one.
Yeah.
And I mean, yeah, you only need two, but these are vertically opposite as well, yeah? So they're similar, yeah? And so for the same reason, the other ones are also similar, yeah? So what you have is you have that from this similar triangle, the ratio of the bases, yeah? X over capital Y is equal to the ratio of this side to this side, yeah? Which is the same as the ratio of this Y to this X from the other triangle. Yeah? You see that? So, I mean, if these two things are true, okay, then, well, you know, like this is saying x over y is equal to x over y, right? And this is saying x over y is equal to y over x. And so that means x over y is equal to y over x. So y equals x. You know? So y is plus or minus x. But they all have to be plus. So x equals y. And that also forces little x. So not only does this get bisected, right? This also gets bisected. Does that make sense? So that's quite a nice little exercise to do for similar triangles because it doesn't use anything complicated, but it does make you use the same thing more than once and try to connect them together. Yeah.